Hi, so for today I'm going to show you a demonstration for the subject BP132, the nervous system 1 and also pharmacotherapy 1. So we're going to focus on the laboratory number 1, which is the membrane potential simulation program, or we call as a MEMPOT. So without further ado, we're going to show you how to do the first practical. So the MEMPOT software that you've seen on the screen is actually designed to stimulate membrane potential measurement in any acceptable cells permeable to potassium and also the calcium ion. So we have different options on the screens. We have the introductions of the MEMPOT, and also we have a few other options. But for today, we're going to show you how to measure the membrane potential on the resting state and also during the action potential. And from that data, we're going to plot a graph based on the resting potential data and also based on the action potential data. So first, we're going to show you how to measure the membrane potential on the resting potential experiment. So we're going to click this button. So we're going to show you this kind of simulation here. So here we have the electrode, and then here we have 5 different cells. So our main purpose is to measure the membrane potential by using the electrode, and we're going to insert the electrode inside each of the different cells here. So from that, we can measure the membrane potential by using the electrode here, and we're going to set the value for the concentration range between 0.5 to 150 millimolar. Okay, so without further ado, we're going to set the concentration for the potassium first. So we're going to click start experiment here, and then we're asking you to set the value for the potassium. So the range should be between 0.5 to 150 millimolar. Okay, so the first value you're going to set at 0.5, which is here. Then after you set the value for 0.5, then we're going to click OK. Okay, and then for now we're going to insert the electrode directly to the cells. So you need to be very careful because you don't want to break the electrode. You also don't want to destroy the cell as well. So what you need to do is you need to insert the electrode directly at the cell. Should be at the membrane of the cell. It should not be inserted too deep into the cells, because it will break the electrode. So we have 2 different control here. We can use this control to move the electrode from up to down, from left to right, or you can use the keyboard, our keyboard, to control the movement of the electrode. Okay, so we're going to use this keyboard. So you can click down to move the electrode. Okay, so the cell will change to the yellow color after each measurement was taken. Okay, so we're going to move the electrode from up to down and left to right, and we're going to insert the electrode from each cells, and we get the first result for the first concentration, which is 0.5. So we're going to proceed with the second concentration. Then you can click OK, and they were asking you to insert the second value for the concentration for the potassium. So it should be between 0.5 to 150. So we can insert the second value, which is 1515. Right, and actually we can use 5 different data for this result. Should be between 0.5 to 150. So the minimum value should be 0.5 and the maximum value should be 150. So the value in between 0.5 to 150 should be in random. Okay, so the second value I put here is actually 1515, and then after you put the value, you can click OK, and we're going to repeat the same thing again. We're going to insert the electrode into the cells. Okay, all right. So here we can see that we have a value here, we have two different concentration, 0.5 and also 15, and also we have the average value for the volt, and also we have the SEM value here. So all of this data actually is very important for the graph, because we need to plot the graph based on this data. So later, after this, we're going to proceed with the other value, which is 0.5, 15, 50, 100, and also 150. So it should be at least 5 different data. So after we record all the data that we put before, which is range between 0.5 to 150 millimolar. So we're going to use this data for we need to plot the graph based on this data. So we're going to click finish experiment first, click this one, and then we need to finish the experiment, click this one, and we're going to finish the experiment. And from here you need to click show report, this button, and this is your data for the first experiment, which is for the resting potential. So from here we can take the picture for this one, and then we're going to copy all the data here and going to paste it on the Microsoft Word. So here we can click screenshot, print screen, and we're going to open the Microsoft Word. So from here we can paste all the data that we have, right? And then going to crop this image. So here we can make it a little bit bigger. So this is your data for the resting potential. So from this data we're going to plot the graph. So what you need to do is need to open the MEMPOT software again, and then from here you need to click the mode, this one. Alright, then from here you need to choose the graph resting potential. So from here you're going to transfer all the data from the resting potential experiment, and we can plot the graph by using this software. So you can click this option. So here they're asking you to enter and edit the data, this button. So you can click this button, and here we're going to put all the data that you already collected before. So for the potassium, we have 5 different data starting from 0.5, we have 15, 50, 100, and also 150. Okay, so we're going to put all the data for the voltage and also for the SEMS, and after that we're going to plot the graph. So after we put all the data into the table, and then I'm going to click OK. So here is 5 different data that already plotted on the screen. So from here you need to adjust the curve fit by adjusting the value of the curve fit. So what you need to do is you need to click the try curve fit, this button, and then they were asking you to put the trial value. So we can click 0.1 and see the line is correct or not. So based on this line, you can see that the position for this line is a little bit higher than the first from the first point. So what you need to do is you need to adjust the value, which is you should be a little bit lower than 0.1. So you can click again try curve fit, and should be lower than 0.1. So we can try 0.05 and see the value is correct or not. So you can see that the value is a little bit lower than the previous one. So you can try again to see the line should be lower than that. So we can try 0.01. See that the line is below than the first point here, so it should be on the point. So we need to adjust it again to 0.0 something. All right. Okay, so we can see that the lines already touch all the point that already plotted on the screens. So from here we're going to print screen the data, going to print screen the graph, and then we're going to paste it on the Microsoft Word. Okay, so from here we can crop the graph again. Alright, so this is your first result for the first experiment, which is for the resting potential. So we're going to proceed with the second part, which is the experiment for the action potential. So now we're going to proceed with the second part, which is the action potential experiment. So actually this is the same step with the first part. So what you need to do is you need to click the action potential experiment, and it will bring you to the same setup. Okay, so what you need to do is you need to put the value for the sodium ion. So it should be between 5 to 150, and you can choose the minimum value should be 5, and also the maximum value should be 150. Okay, and you can choose the random value in between 5 to 150. So you can click the start experiment, and they're asking you the value here, 5 to 150, and you're going to choose the value in between that. It should be 5 different value, and you're going to do the same activity as before. You're going to insert the electrode inside the cells, and then you're going to record the membrane potential for each different concentration of the sodium. Okay, so you're going to start with 5 until 150. So after the experiment, this is the report that we can get for the action potential experiment. So we have 5 different data starting from 5 to 150 concentration for the sodium, and also we have the different action potential data for 5 different concentrations that already recorded. So from here we're going to do the same thing. We're going to transfer all the data from this report, and we're going to transfer it to the graph of the action potential, and from that we're going to plot the graph for the action potential. So now we're going to transfer all the data from the report to the graph for the action potential. So we're going to click the mode button, and then we're going to click on the graph for the action potential, because we want to plot the graph for the action potential. So we're going to do the same thing. We're going to enter all the data that already recorded for the previous experiment. So we already recorded 5 different data for the concentration for the sodium, starting from 5, then 15, and then 50, 100, and also 150. Okay, so we're going to proceed by adding the data for the action potential and also the data for the SEM, and then after that we can proceed by plotting the graph for the action potential. So this is the result that we get after we key in all the data from the previous report. So we can see that we have 5 different points on the screen, and you need to find the best curve fit for a graph. So you need to make sure that the first point and also the last point should be connected, and the point at the middle should be balanced, which is one at the bottom and one at the top. So this is the best curve fit for the second experiment, which is for the action potential graph.